Welcome back, class. As I mentioned, as we kind of wound up the last section, we're going to talk about arc elasticity. And the one of the issues, and the text went into, I don't want to say great detail about it, but they certainly touched on it, is that when you're calculating the price elasticity of demand or PED, it does depend on where you start, which data points that you use as, you know, kind of your end and your beginning, and both in price and both in quantity demanded. And we're going to talk about arc elasticity. And just before we get too far along the way, the last time I taught this class to a group of undergraduate students, I had a test that had some fill in the blank, and I can't remember exactly how phrased the question, but it was complete these thoughts or complete these sentences, and one of them was about arc elasticity. And one of the students answered, I guess he got a little confused because he said the answer to the question was arc, A-R-K, elasticity, and it's not arc, A-R-K, elasticity, it's A-R-C. And I realize I have a Southern accent, and this young man was probably having a little trouble with my accent, but it's definitely not arc, A-R-K, it's A-R-C, elasticity. And the definition, especially in the text, is the measure of elasticity based on the percent changes relative to the average value of each variable between the 2 points. So you're looking at in the ratio, you're looking at 2 points on quantity demanded, and you're looking at 2 points on prices. And arc elasticity doesn't care where, what the new one is or what the old one is, because they're going to take those 2 points and they are going to average them. So if you're looking at price, let's say one price point is 50 cents and the other price point's $1, and the average is going to be what? 75 cents. And so if you're looking at that as your example, and the example that they give you in the text is the arc elasticity of demand is the arc percentage change in quantity demanded, and you calculate that, you're going to calculate the numerator now. You're going to have the change in quantity demanded. And let's say your change in quantity demanded was, it went from, I don't know, we'll just pick 100 to 80. So the change in quantity demanded was 20, and you're going to divide that 20 by the average, and 100 plus 80 is 90. So quantity demanded on your numerator up here is going to be 20 divided by 90. And in your denominator, what did I say? 100 at $1.50. So the difference is 50 cents divided by 75 cents. And that's the way you're going to set that ratio up. And that ratio at that point, and the numbers might not have made sense on the ratio, but I just want to make sure you understand the concept. And there's several problems in the text. That's what you're going to end up. You're going to end up with the ratio. And again, it's going to give you a price elasticity of demand that probably gives you a better approximation of reality. And it's taking the guesswork out of, when you're calculating the percentage change in quantity demanded in price, it's taking the guesswork out of which points you start with and which points you end with in the original form that you looked at. So very helpful, at least from my perspective, when you're looking at price elasticity. And again, Ohio State, the professors, it was like, they liked the price elasticity of demand, but they would always gravitate to the arc price elasticity because they all felt that gave you a better approximation of reality. And they that was what they expected you to use on the test when you were working through problems. And arc elasticity, it's the value at the midpoint. And in some texts, I've seen it called the midpoint method. I can't remember whether they refer to it in this text or not, but I have seen the reference in other texts in the past. And then they talk about the arc elasticity on the linear demand curve. And the elasticity of demand becomes less elastic as we travel down the demand curve. So demand curves, negative slope, it's downward sloping. And as you travel down that demand curve and get closer to the bottom of that demand curve or closer to the x-axis, however you want to look at it, the elasticity of demand becomes less elastic. And the absolute value becomes smaller. Remember, as you're moving away from elasticity, so it's got to be absolute value. It's got to be greater than 1 to be elastic. If it's less than 1, it's going to be inelastic. And so the elasticity of demand is going to change as it goes down that negative or linear demand curve. Remember, in the last segment, we said the slope isn't changing of the linear demand curve, but the price elasticity of demand is changing as you go down that linear demand curve. Up here in the upper end of your curve, or the part of the curve that's closest to, in a general sense, closer to the y-axis, the price is high, quantities are low. The percent change in quantity demanded is relatively large, and the percent change in price is relatively small up in this upper end of the demand curve. And that gives you a price elasticity of demand of something greater than 1. So this upper end of your demand curve is elastic. As you go toward the lower end of the demand curve, so the part of your demand curve that's down here closer to the x-axis, prices are low and quantities high. Remember, over here on the you got your prices sitting over here on the y-axis, so you know that down here on this end, prices are going to be low and quantities high. The percentage change in quantity demanded is relatively small, and the percentage change in price is quite large, and that gives you a absolute value less than 1. And remember, go back to your ratios if you're having trouble thinking through this. Think about numerators and denominators in those ratios, and it's going to be inelastic. And at the midpoint of that downward sloping demand curve, the percent change in quantity demanded equals the percent change in price, and we have unit elasticity because the price elasticity of demand equals 1. So keep that in mind, because now we're going to start using those observations depending on where you are on the demand curve, and talk about some issues with total revenue. And if you remember the examples in the textbook, I think it was an individual. I think the individual was trying to forecast revenue by changing the price of like a subway ticket or public transportation. As I was reading it, I was thinking about the metro in DC, but I think maybe we're just talking about public transportation, but she was talking about, or the individual in the example in the textbook was talking about what the impact was on total revenue. And total revenue is defined as the firm's output multiplied by the price at which it sells that output. Total revenue, P times Q, price times quantity. Really simple mathematical equation. And it doesn't matter what market economy you work in. You can work in healthcare, you can work in computers, you can work in a service industry, you can work in manufacturing, you can be a salesman, at your car dealership. It doesn't matter. doesn't matter what the market economy is, total revenue is still price times quantity. And as you look at total revenue, and I think in the example in the book, they may have had the elasticity of price elasticity of demand up here in the upper end of the demand curve, like at a -3, and it was a -1 at the midpoint, and maybe -0.33 at the bottom. And that's where they use these numbers. And if you go back to the text does a pretty decent job of kind of explaining this. And I think they want to give you as a student an opportunity to kind of have some different tools in your toolbox. And again, that's what we're trying to provide you in this class, is tools to put in your toolbox to make you successful, either as you finish up your scholastic career or your academic career, or when you get out into the workforce. You want to be successful, and you want to be viewed as a valuable asset for the corporation or companies you're working for. And so they give you these little arrow things. And so total revenue, when you're looking at a -3 up at the top, that means one arrow going up for price and 3 arrows going down for quantity. And they allow you to take and net the arrow, what they call net the arrows out. And so if you net the arrows out there, you've got total revenue is going to drop by 2 arrows if you raise the price by 1 arrow, because the quantity is going to drop by 3 arrows. They're not really giving you numbers. They're just, they're saying that in general, you may not need numbers, but you can take this, what I think they call it the arrow method, and it will show you that. So basically, if you're up at the top of that a downward sloping demand curve and you raise price 1%, what's going to happen to quantity? Going to drop 3%. And the net result is total revenue drops 2%. So 1% up on price, 3% down on quantity gives you a net of 2% down on total revenue. And then they go to the example on the lower part of the curve. And if they raise price by 3%, because remember the number that they were using in the example was 0.33. If they raise price by 3%, quantity only goes down 1%, total revenue goes up, as you net it out, 2%. So if you're trying to increase total revenue, and you're going to want to do it by price, you want to be down here in this lower part of the linear demand curve. And why do you want to be down in that area? It's because it's the area where price elasticity of demand is in absolute value less than 1. It's inelastic. And remember what we said at the very first part of the chapter. Inelastic means inflexible. If you're up here at the upper end of the demand curve, it's elastic, and there's a lot of flexibility up here. Remember, it's like a rubber band. It's stretchable. And so if you're trying to make decisions on how to raise total revenue by playing around with prices and quantities, you want to be down here in the bottom. And if you're at the midpoint, it's not going to matter. You raise price by 1%, quantity is going to drop by 1%. If you drop price by 1%, quantity increases by 1%. And you net those out, and it's no change. They have total revenue with a bar across the top of it, which means no change. And the midpoint of the demand curve actually maximizes your revenues. So if you're in a situation where you're trying to maximize revenues, you want to be at the midpoint of that demand curve, because that is what? Unit elasticity. And they go through, so they kind of take the route of going through the negative signs, and then they go down to, and they start trying to explain it, at least in the text, on the absolute value signs. And if the absolute value is greater than 1, then as price increases, remember, it's greater than 1. So what does that mean? It's elastic. What part of the curve are you in? You're up in this upper part, I'll say upper half of the curve. So as you increase price, what's going to happen to revenue? Total revenue going to go down. Decrease price, total revenue comes up. That's what happens up here in this upper part. If you're down here in the lower part where it's the absolute value is less than 1, what did we find out? Increased price, increased total revenue, right? Decreased price, decreased total revenue. Because based on the elasticity, the magnitude of the price is either going to be above or below the magnitude of the quantity demanded. And that's what's going to drive your revenue. And if you, in that midpoint where you're trying to maximize revenues, price goes up, price goes down. Makes no difference on the quantity demanded. And because it makes no difference on the quantity demanded, the total revenue, there is no change in it. And that is where the total revenue is maximized. And then they spend a few minutes talking about some, I don't want to say weird demand curves, but demand curves that occasionally you'll see. And if the price elasticity of demand is 0, so that means it's a vertical demand curve, they talk about that as being perfectly inelastic. I think the example they give in the text is insulin, because it doesn't matter if you're a diabetic, you got to have that insulin no matter what the price is. So you can change the price however you want to. It's not going to have any impact on the quantity demanded. They're going to be the same quantity demanded. If the price elasticity of demand is infinite, that means as the percentage change in price approaches 0, so as it approaches 0, then that ratio does what? It blows up and it starts to approach infinity. And that's where your demand curve is perfectly horizontal. And they give the example in the book of about a bushel of wheat. And I think they said if a bushel of wheat's $4, everybody can get $4 for that bushel of wheat. So the percentage change isn't going to matter. Why would you pay $5 for a bushel of wheat when you can get it for $4? Or why would you sell it for $3 if you can sell it for $4? So the price elasticity of demand on that horizontal, when I say horizontal to the x-axis, or the quantity axis, it's going to be start to approach infinity. And then, and so if it's flat, it's going to be perfectly elastic. If it's vertical, it's going to be perfectly inelastic. And lastly, they start to talk about a couple of things. They kind of throw them in there down toward the tail end, talking about the determinants of PED, or price elasticity of demand, and availability of substitutes. If the price elasticity of demand is greater than 1 in absolute value, the more close substitutes. And the closer, when you're looking at substitutes, depends on how you define the market. And they use food as an example of defining the market. So the narrower you make it, the more highly elastic it is. And they talk about, I think the example is if you define food down to cereal and cereal down to Captain Crunch, that's going to be highly elastic. Another thing that comes to mind to me as far as available substitutes, if you think about how healthcare has changed over, well, let's say over the last 5 years. We've survived COVID, but healthcare has changed. And so now if you look at a visit to your doctor's office, there's a lot of substitutes. There's telehealth. I can pick up the phone and, you know, call a provider and talk to them on the phone. And if I have a pretty good idea what's wrong with me, as long as that individual will give me the medication I need, I'm fine with telehealth. You can go to urgent care. Seems like there's a urgent care on every street corner in Atlanta. I mean, every time you turn around, there's an urgent care. You've got holistic healing. You've got Far East acupuncture. I mean, there are a lot of substitutes for a primary care visit or a visit to your doctor's office. So what does that say about doctor's office visits? They may not be perfectly inelastic, but if you've got, I mean, perfectly elastic, but if you've got a lot of substitutes, you're going to be highly elastic. Also, household budgets, the percent of disposable income spending on product. And if you've got a greater percent of your budget, and they talk about budget share in the text, but a greater percent of your budget, the greater budget share, it's going to be the more elastic. And then lastly, they talk about the time horizon. The longer the time horizon, the more elastic it's going to be. And I think the example they may have given you in the book is electricity. So if you knew ahead of time that like a year in advance, you're going to get a huge bump in kilowatt hours and the price of kilowatt hours, you're going to start doing some things to try to make your house more efficient. Going to put in foam insulation in the attic. You're going to put weather stripping on the doors and windows. You may set up if you're in an area like Atlanta or even Nashville, where there's a lot of sunshine, you may try to set up some solar cells, maybe put a solar cell in your roof. So time horizon, household budgets, availability of substitutes all have an impact on how elastic a particular price elasticity of demand number actually comes out to be. That's going to kind of wrap up the price elasticity of demand. Again, we've talked about Arc Elasticity. We've talked about just the general price elasticity of demand, what drives it, how it impacts where you are on that negative sloping demand curve. And then we're going to come back in a few minutes and kind of try to wind this chapter 5 up and talk about, I don't want to say some unique approaches to elasticities, but it's some approaches to elasticity that you'll see in textbooks or you'll see in journal articles, or you actually one of them we're going to talk about is income elasticity demand. And I heard it's in an individual on, I can't remember this Fox Business, something on Fox, one of the Fox shows, talking about income elasticity of demand, I don't know, last week or something. So when we come back, we are going to wind up this chapter 5 and kind of get this third segment in the books. Talk to everybody soon. Thanks.